much for joining. This is, of course, a liquid handling for lab automation presented by Festo. I'm joined today by our presenter, Mike Pistulka from Festo. Mike, care to share a little bit about yourself and about Festo, please?
Yeah, I sure can. So let me just pull my screen here, and I'll start the presentation. That way it'll kind of give you a little overview too. So welcome everyone. Thank you for joining. My name is Mike Pistulka. I support the life sciences group inside of Festo. If you don't know Festo, we're a worldwide company. We have about 33,000 products in pneumatics, electronics, electric drives, belt drive, ball screw, lead screw products. We have a lot of different market sectors that we're involved in, the food and beverage, the packaging, semiconductor, automotive, and one of the market sectors is the life science group, which I'm a part of. So it's laboratory support, fluidic handling, and supporting the medical device arena as well. I show this slide in front of you. I have support design engineer Graham Taft. I also have Eldon Goddard, who is actually on this call here today. So I'll hand the baton to him as well to kind of go through some software info as we get to that. So he's an application engineer. So with that being said, a couple things that we're going to go over today is just a little intro. We're gonna review some laboratory terminology and markets. I don't know what the audience is here, so I thought I'd just spend a couple minutes just going through that. We'll go through Festo's method for their fluid handling concept and the architecture to that. We'll review valve control for high precision, and then liquid handling solutions, various components that Festo supports in the liquid handling process. We'll talk then about some new technology that Festo is releasing and developing, and then we'll also show a few short videos and then a follow-up overview. So with that, we'll get started. So hopefully we don't bore anyone, but laboratory terminology, this is some of the terminology that you'll see in the laboratory industry. Microtiter plates, 96, 384, and 1536 well plates are kind of the common. Some of the various liquid terminology that you'll hear in terms of dispensing or aspirating, or you'll start with liters, milliliters, microliters, nanoliters, and it goes down to picoliters. And we work very well down to the nanoliter level. And just to give you a perspective, if you're not familiar with microfluidics, when I like to kind of indicate that basically a drop of water is about 50 microliters, and we play quite well in the 1 to 10 microliter level, 1 microliter. So it's we're getting close to that nanoliter dispense rates. But then some of the other terminology, aspirate is obviously to pull a vacuum into the pipette, dispense is to basically spit the liquid out. An assay is basically an investigative procedure. So if you're hearing about laboratory customers, mixing and doing different cocktails, if you will, you'll consider that as an assay. And then PCR is basically doing a heating and a cooling, basically to basically try to replicate similar to like DNA processing. So polymerase chain reaction or PCR. The microtiter plates come in a variety of different well capacities. But again, the 96, the 384, and the 1536 are most common, and the most common is probably the 96 as well. So this is what you would see if we're talking about the microtiter plates. Some of the different markets that support the mechanical support and liquid handling support in the laboratory markets. So various assays, cell biology, cell culture, clinical diagnostics, down to micro plate dispensing, handlers, readers, sealers, transfer, wash. So there's a lot to do with various mechanical portions for supporting this industry as well. So if I talk about Festo's methods for fluid handling and their concept and their architecture, Festo, there's a lot of different pumping methods. There are various pump methods. Festo does a pressure over liquid based method for dispensing. Um, and we have what we call a PGVA. It's a pressure vacuum system. So inside of this unit, basically we have inside of this unit is an onboard compressor. We have three different chambers. One basically filters the air coming into it down to a zero point 0.1 micron, so very fine, clean air. Then there's two other chambers. One facilitates the vacuum and the other facilitates the pressure. So we utilize this to basically pull vacuum and add pressure. So we're able to aspirate into a tip and dispense out of a tip. And we do this through piezo technology. On board here, you see this little box. I don't know if you, hopefully you can see my pointer, but there's a piezo proportional pressure and vacuum regulator in there that gives us the fine-tuned minus 500 to plus 500 millibar. On this unit, there's a single pneumatic port that facilitates both pressure and vacuum. And then obviously we have the connections for the power supply and RJ45 for Ethernet and Modbus TCP. So you can integrate this into a PLC. So basically the software with that, there's a GUI instruction to function this unit, and I am going to turn this over to Eldon. I'm going to let Eldon do a little demo of this pressure vacuum system, and then we'll talk a little bit more about the architecture of that as well.
The
We can see it. It's up. It looks like it's up, Eldon.
good. Okay. So I'll just kind of overview the GUI here. I am actually connected to a PGVA currently. I can disconnect. I'm connected through a serial port, but you can also connect through an Ethernet port. Once you're connected, you can change the default IP address, which can be helpful. So what you set here, this is the desired vacuum and pressure inside of the internal chambers, and you can set them up to 1 bar. This is in millibar, but usually 600 is plenty for application. So in the output pressure, this is where you'll actually set what pressure you're going to send to the valve. We can put it at minus 300. I don't know if you guys can hear in the background it actually changing.
We can, but the compressor typically comes on and at the pressures and vacuums of the chambers. So it's very quiet, but it shuts off after it gets to the desired pressure and vacuum.
Yeah, and so it usually will only change when you're changing this output pressure or if you're doing a lot of dispenses. Otherwise, it pretty much maintains the pressure pretty well. And to send a signal to dispense the valve, I currently have the valve hooked up to our VAM, our valve controller, so it actually wouldn't open the valve because I don't have it set up to the PGVA, but you can choose to either aspirate or dispense from here, and you just set your pressure you want to dispense at or aspirate at, and then your opening time. So it's pretty straightforward GUI. There's not a lot to it.
Okay, so this is the architecture for the open loop pipetting. So basically, you can utilize the host controller PC to function the pressure vacuum box, and then you can obviously control a single valve multi. Here's an 8-channel, and then here's a 96 channel. So this vacuum unit will give you the ability to aspirate and dispense with a variety of different options for valve technology. What that pressure vacuum system really does for you as well, if you're building this into your platform, it gives you a pneumatic source. If a customer doesn't have a pneumatic wall source, it really gives you an onboard pneumatics to function the control. So this again is kind of gives you a little idea that the pressure vacuum system can be utilized also in a bulk dispense. So basically here we're taking this has the air compressor, the pressure controller, and the vacuum all embedded into the unit. So here we're basically pressurizing a liquid reservoir, and then we're turning a valve on. So we're basically the way we're getting our dispense rates and accuracies and repeatabilities is by the pressure control. The on-off time of the valve, nozzle size, orifice sizing, and then obviously if you needed to do accurate testing, you would do that through a scale or balance table. So. We'll talk a little bit about valve control. So we have a valve controller that can be integrated into this system as well, and it's this little unit is very high precision. It has a very high resolution, 0.2 milliseconds, so very fast. This unit can be used for any type of valve. And it's capable of functioning up to 8 valves. So it's about the size of a pack of cigarettes. And it also has a GUI instruction, which is quite intuitive and really works quite well with valve control. And if you're really looking for higher precision and higher accuracy and higher repeatabilities, you would potentially add one of these units in. And I'll turn this over again to Eldon to kind of share the GUI instruction. And what's neat about this is you can independently manipulate each channel.
Well, here is our VAM GUI, and I'm currently connected through the Ethernet port. I'll disconnect to show you guys. So when you're disconnected, these tabs are all blocked out, and you won't be able to reach them until it actually is connected. When you go to the control, this is where you'll select the valves that you have hooked up to the valve controller, and you can individualize these variables for each valve. I currently only have one valve on there. So these parameters here, actuation time, inrush, and tau, when they say times 0.2 milliseconds, that means whatever number you have in here is multiplied by 0.2 milliseconds. So this will actually open for 1 second. A little bit confusing, but once you use it, it's pretty straightforward. Once you change the settings, it's good always to save it. Internal start mode means that we are going to actuate the valve from this GUI instead of externally actuate it or manually trigger the valve from an output. So if we watch, we may be able to see the output pressure drop. It's such a small valve, we probably won't, but yeah. So you can see when I actuate it, and you saw the pressure drop momentarily. So this is probably the key tab you're going to work in terms of regulating the valve to the dispense you're trying to get. But you can go, if you want, and look at your actual output, what the valve actually did, the measured current from the valve from each actuation, and you can pick which valve you want. Obviously, we're only running valve 1. Your status word tab is basically your error bits. This is just used to look at the status of the valve, and if there is an error, to see which error it is. System info is just a general overview of the VAM, the part number. Ethernet is where you will change the IP address if you want to. when you change the IP address, you have to hit set IP address, and then you have to power cycle the unit. That is key to resetting the IP address. If you don't power cycle it, it won't reset. And this GUI is also very straightforward and pretty user-friendly.
So can you go back to the dashboard again? A couple things that I wanted to mention.
Yep.
So on this dashboard, as I mentioned, each independent channel you can manipulate. So on the left-hand side, you'll see rated voltage, you'll see inrush current and holding current, and you can manipulate that. And the reason for this ability to manipulate is if you're really getting down to some really tight accuracies, like or dispense rates down to the 1 microliter level, and you want a good dispense rate across all channels, all 8 channels. When you have a mechanical valve that you're actuating on and off, there might be some inconsistencies, right? Because it's a mechanical device, and so you're able to manipulate that current to base. So if you start doing some testing, valve 2 may function a bit different than valve 1, and you want to kind of toe that in and have the same dispense rate. So you can manipulate that current level to bring them all into the same dispense levels. The same with the right side. You'll see, the inrush time or the actuation time. So you can manipulate that actuation time. So it might take, another couple milliseconds more, to dispense the same rate on valve 2 as it does on valve 1. So it's just playing around, manipulating, and then so it's really kind of a unique piece of software. So hopefully that gives you a little more of an idea of how this GUI instruction works. So this is the architecture for integrating that control in for the valves. You can actually function the valve, an independent valve with the PGVA, but if you're really wanting to get higher precision control, you would add this VAEM controller to really get higher precision and resolution. On the right-hand side here, you'll see kind of a typical Festo system, right? You see the reservoirs. You'll see a pneumatic system here, but basically that pressure vacuum system takes control of that in that position. And then obviously Festo has electric drives, belt drive, ball screw, lead screw products that can support an XYZ gantry system as well. And we'll get to some of the videos that we display as well. So I wanted to take a few minutes to kind of go through some of the liquid handling solutions that Festo has in terms of some of the components that we support for that process. So Festo has a number of different valves, and they can be configured into a number of different arrangements. Here you see a single channel, you see a 4-channel. Here's an integrated sub-D style 8-channel unit that's basically 9mm pitch for dispensing into a 96-channel microplate. So independent control of each valve, inlet and outlet for dispensing those fluids. We also have a product called our VTOI, which comes in a single valve design and a slice of 8 independent channels there as well. So basically, you're utilizing one valve to dispense 8 channels, and those the layers in this Ultem manifold here that you see are precise channeling. So you're getting the same dispense rate across each channel. You can sandwich these together in multiple configurations up to even this 96 channel where you're utilizing 12 valves to dispense into 96 channels. We'll go into some more valves. We've released a VYKA, a VIKA, a VIK-B, and a VIK-C valve, and they're just I won't go into the weeds with all the the technology of this. It's just more, giving you an idea of different valve sizes, different dispense rates, things of that nature. So the Vika is a 7 millimeter valve that we released, and it's probably services probably 85 to 90% of the applications. And it's a rocker style valve. So internally here, basically the only wetted parts that you see here are in this light tan area, right? The liquids come in, there's basically a rocker, and there's a seal here that facilitates the liquids. So you're never, so the electronics and anything above that tan portion does not really see any further liquid. So it's an isolation style valve. So hopefully it kind of gives you an idea of the characteristics of that valve. And obviously, the valve comes in a lot of different arrangements. We can do compatibilities on liquids and give you, EPDM, FKM, FFKM seals to meet some of those compatibilities. And the same with, the manifold materials. Typically, we're working with PEEK, which is pretty resilient when it comes to various chemicals, but we can certainly do those compatibility checks as well. It's a very good valve in terms of flushability because you basically have a rubber membrane, if you will, that's coming off seat, and you really have minimal nooks and crannies that harbor potential dead areas, dead space in the valves. We've released a VYKB and a VZDB. The VZDB on the right is a pneumatically controlled. So we've had customers that may have a application that requires explosion proof. So we can certainly utilize a pneumatic operated valve as opposed to a electric solenoid. And there it is again. And then the VYKC, which is a similar style valve as our smaller VYKA, which is a rocker style, but this is a larger valve, and it allows for higher dispense rates. It's not going to probably have the accuracies on the low end side of it, but it's going to be able to dispense higher fluids, higher volume liquids. And again, same principle, rocker style internal valve, with various options for seals and liquid materials. Now I want to talk a little bit about Festo's new technology. I just got done explaining Festo's methodology for open loop. So basically, we're in our open loop technology, we were using a pressure over liquid. We were utilizing pressure, the on-off time of the valve, and it's kind of a algorithm that you develop based on what you want to dispense, right? So the intelligent pipette that is soon to be released here is our DHOP, and this has onboard smarts to it. This is the architecture for the layout of the PGVA. It's a decentralized pressure vacuum generator. The difference between this and the open loop is it takes a different controller to start with. This has the PGVA2, so it's a different vacuum generator, a lot of the same components internally, but it has two pneumatic ports, one for pressure and one for vacuum. It also has, the two electrical connections for power, and then obviously bus technology for the Ethernet and Modbus. So you can actually function this unit. It's got internal, the internal has piezo control. It also has a mechanical link here for ejecting the tips. It also has internal airlock pressure sensor, so you can actually plug in, for instance, if you wanted to aspirate and dispense 2 microliters, you can plug that in and it will aspirate 2 microliters and dispense 2 microliters. And it doesn't matter what the viscosity is. It takes that into account because there's an airlock sensor between the liquid and the internal sensor that measures that liquid volume that you're pulling in, and it's very accurate. It has the tip sensing ability as well, and we can also integrate liquid level detection as well. So this unit will be very accurate, and it will have closed loop technology. You can stack this unit. It's 18 millimeter pitch to it, so you'd be able to utilize this for dispensing into a 96 channel plate, but you'd have to make 2 passes, right? It's just sandwiched into an 18 millimeter pitch. Very high CV. So when we talk about CV, we talk about the repeatability of dispensing. And typically customers like to see under 5% CV. And here at 1,000 microliters, we're at 1% CV. And obviously those that CV accuracy tends to drift up as the dispense rates come down, right? As you start getting towards that 1 microliter level, I think on this unit we go to 4%, which is still very, very good from an accuracy standpoint. Yeah, just a few of the characteristics. So yeah, this unit is starting to be released. We are having pilot customers do some testing with this, so it's kind of an exciting product that I'm looking forward to in terms of closed loop feedback. This is the simple architecture. You can basically function with a PLC right to the vacuum generator and plug in. The smarts will actually be built into right into the pipette unit itself, and then you'll have that closed loop connection back to the PLC. I want to show a few videos now, just a few things to kind of give you an idea of some different things that Festo does in terms of some of our custom solutions. This is actually our open loop pipetter, but on this unit, you'll see a fork mechanism there, and you'll also see that over here on the left. And basically, if you're integrating this into a Z-axis, you can utilize that against a hard stop to eject the tip. You set the tip, and then you can eject the tip. And this just will be a video here, just kind of giving you a short overview of how that fork mechanism functions. So you can set the tip, you can do an aspiration, you can dispense into the microplate, and then obviously where you don't want cross contamination, you're ridding that tip by ejecting it and then going back to set another tip as well. So the next video, sorry, I kind of cut that short, but this is a unique custom solution that we came up with. Basically, it's a valve on a manifold, and we created a reservoir internally into that manifold. So customers that either are doing bulk dispensing or they want another method of aspirating into a reservoir and then dispensing small amount or various amounts, small amounts of liquids out, they can do that. So this kind of gives you a little video of aspirating those liquids in, and they go through the valve and then into the reservoir, and then obviously you can go and index your dispensing into micro titer plates. This dispensing here now is actually dispensing 1 microliter, so 1/50th of a drop of water, if you will, very accurately. So you can see that dispensing and indexing and dispensing into that 96 channel microplate. This next video is a 8 station, eight channel distributor, and get that started here. This unit is basically a single valve 8 channel unit. So you'll see you'll hear the valves clicking on and off. And then we're just indexing. This is a 384 microplate, tighter plate. And when we talk about 384, 96, 1536, it's the number of channels that are actually in the same footprint, if you will. This unit, back up here again. So we had an application that came up in Europe, and it was a very high throughput application. And the customer, this is a 1536 micro tighter plate. So there's 1536 wells in this micro plate in the same footprint that a 96 is, correct? So they came to us and they wanted to have a very high throughput, and we were able to dispense utilizing an 8 channel dispense unit in 15 seconds. And this kind of sounds like a machine gun when it goes, but it takes into account coming down each row and dispensing 1 microliter into this 1536 well, and turning the corner and coming back down the next rows. And this is a 4-pass unit, but it does it. It performs this process in 15 seconds. So yeah, so that was an application that came up in Europe that we worked on. So, and then yeah, the final slide I have here is basically kind of an idea of as a Festo is a one-stop shop. We have we support our control technology, which includes that little VAEM controller for valve technology. We have vision systems for barcode reading, things of that nature as well. We obviously have the plumbing arrangement for connectors for fittings and tubing and in various connections, right? And then a full air prep, which includes our piezo technology and the pressure vacuum system to give you an onboard pneumatic system for this technology. We also have a plethora of electric drives, we call it. Our servo motors, stepper motors, belt drive, ball screw, lead screw products in a lot of different configurations. So we can, obviously tailor a specific application with the needs and provide a product for that as well. Here you see a little EXCM gantry system, which is a dual motor X and Y. And then we integrated a Z-axis into that. And the nice thing about that is you can put your motor, you can drop this thing right onto a table and have all your ICE or your cables in your motor and controls and everything underneath, and just have a nice clean upper table. We also have rotating and gripping. I'll show you another video here, kind of what a standard Festo system would kind of look like, but it would integrate capping and decapping as well. So this is like this EHMD that you see or on the right-hand side here is a gripper and a rotary unit. So we can integrate that in as well. And then obviously we went through a lot of the dispensing valves and the pipetting technology as well, including tips and our new smart pipette controller. So with that being said, I do want to show this video. This is a typical system. We have a new product called our EXCL, which is actually a low-cost gantry system that we have. It's actually configurable in a couple, in various stroke lengths, in the X and the Y. And you can integrate two Z-axes on the same, on the same system here as well. On the right-hand side, we have a capper decapper. I'll just start playing the video and kind of narrate it. But so you'll see the capper decapper grips, picks up the vial. We actually turn it to do a barcode reader. You'll see the camera in the back. Decap the unit. We're aspirating out of that vial and then dispensing that into a 96 channel microplate. And then disposing of the tip, and then we're setting a new tip to start the process all over again. So it's kind of a nice, as I mentioned, one-stop shop. Here you'll see the capper decapper brings the vial in, another gripper grips it, and we're doing that barcode read. We're dispensing, or excuse me, aspirating and dispensing into that micro titer plate. Here we'll get a little bit of a close up on the dispense process as well. That's it in a nutshell.